somewhere between 30 and 50 million people died. Not from a war, not from a plague, at least not directly. From a shift in ocean temperature thousands of miles away in the Pacific, a shift most of the people who died from it never knew existed. Florence Nightingale called it a record of human suffering the world would take generations to comprehend. It remains, by every serious historical estimate, the deadliest environmental disaster in recorded human history, and almost nobody watching this has ever heard its name. And right now, in 2026, meteorologists are watching ocean temperatures in that exact same stretch of Pacific climb toward numbers that some models suggest could rival, or even exceed, the event that caused it. Today, we're breaking down exactly what happened during the Great Famine of 1876 to 1878, why a single climate pattern was capable of killing tens of millions of people across 3 continents, and why scientists are genuinely asking whether the El Niño developing right now could turn out to be even more extreme. Here's what makes this comparison genuinely different from typical disaster history content. This isn't a story about a hurricane or an earthquake, a disaster you can watch unfold in real time on camera. This is a disaster driven by a shift in ocean temperature so gradual, so distant from where the actual deaths occurred, that most of the people who died never understood what had caused their crops to fail 3 years running. And the exact same invisible mechanism is measurably, verifiably building again right now, tracked by satellites and ocean buoys the 19th century never had. Which means, for the first time in human history, we get to watch this specific kind of catastrophe develop with months of advance warning instead of none at all. Let's start with what actually happened, because the scale of this disaster is almost difficult to process even by the standards of history's worst catastrophes. Beginning in 1876 and stretching into 1878, a sequence of catastrophic droughts struck simultaneously across India, China, Brazil, and parts of Africa, triggering famines so severe that the death toll, when historians and climate scientists finally attempted to calculate it more than a century later, landed somewhere between 30 and 60 million people, with most rigorous estimates converging around 50 million. To put that number in context, it represented somewhere between 3 and 4% of the entire global population at the time, vanishing in the space of roughly 2 years. In India alone, under British colonial rule, the famine killed somewhere between 5.6 and 9.6 million people by conservative estimates, with some historical reconstructions placing the toll as high as 12 to 29 million, when accounting for the full extent of the crisis across the Deccan Plateau and surrounding regions. In northern China, a catastrophic famine now remembered as the Dingwu famine killed between 9.5 and 13 million people, concentrated heavily in Shaanxi province, where an estimated 5.5 million people died, alongside major losses across Zili, Henan, and Shandong provinces. Brazil's northeast endured what's remembered as the Grande Seca, the Great Drought, a multi-year catastrophe that devastated the region's population and economy. Climate scientist Deepti Singh, who has spent years studying this specific period at Washington State University and previously at Columbia University's Lamont Doherty Earth Observatory, has described the resulting global catastrophe in blunt terms, calling it arguably the worst environmental disaster ever to befall humanity, a description that historians studying the period have found genuinely difficult to dispute. To understand how a single climate pattern could reach across 3 separate continents and kill tens of millions of people in less than 2 years, you need to understand exactly what was happening in the Pacific Ocean at the time, because the mechanism driving this disaster turned out to be extraordinary, even by the standards of a phenomenon scientists already knew could reshape global weather. El Niño is the warm phase of a naturally recurring climate pattern called the El Niño Southern Oscillation, occurring every 2 to 7 years as trade winds across the tropical Pacific weaken, allowing unusually warm water that normally sits pooled near Indonesia and the western Pacific to spread eastward toward South America. That shift in ocean temperature doesn't stay contained to the Pacific. It reshapes atmospheric circulation patterns across the entire planet, altering rainfall, temperature, and storm behavior on essentially every continent simultaneously, sometimes bringing devastating floods to one region while triggering equally devastating drought thousands of miles away in another. Most El Niño events are moderate. Occasionally one is genuinely extreme, and researchers have coined the term Super El Niño for the rare cases where sea surface temperatures in the benchmark Nino 3. The 4 region of the Central Pacific climb at least 2 degrees Celsius above the seasonal baseline, an unusually large departure from normal conditions. It's worth understanding why a shift centered thousands of miles away in the middle of the Pacific Ocean can so thoroughly disrupt weather patterns on the opposite side of the planet, because the mechanism isn't intuitive at first glance. The ocean and atmosphere are far more tightly coupled than most people realize. Shifting the location of the warmest surface water in the tropical Pacific fundamentally alters where the strongest convection, rising, moisture-laden air actually forms, and that convection pattern acts almost like a switch controlling the position of the jet streams and major wind belts that circle the entire globe. Move the switch, and monsoon rains that reliably arrive in India every summer can weaken or fail entirely. Push it further, and the same shift can simultaneously suppress rainfall across northern China, disrupt the trade winds that normally bring moisture to northeastern Brazil, and alter atmospheric pressure patterns as far away as southern Africa, all from the exact same underlying disruption in the tropical Pacific. This is precisely why a single El Niño event, however localized its actual origin point might seem, is capable of triggering genuinely simultaneous agricultural catastrophes on 3 or more continents at once, a mechanism 19th century observers experienced firsthand without any way to understand what was actually connecting their separate, seemingly unrelated local disasters. The 1877-1878 El Niño remains, by the estimates of climate scientists who have painstakingly reconstructed it using tree ring data, historical rainfall records, and other indirect climate proxies, the most powerful El Niño event identified in over 150 years of reconstructed climate history. Researchers estimate that water temperatures in that key benchmark region of the Pacific may have soared as much as 2.8 degrees Celsius above seasonal norms, a departure more extreme than any El Niño documented within living memory at the time this research was conducted. And the setup behind that extreme event turned out to be almost as significant as the event itself. Researchers studying the period found that the tropical Pacific had experienced an unusually prolonged stretch of cooler than average water temperatures from roughly 1870 through 1876, the longest such cool stretch on record at the time, an extended period that appears to have allowed an enormous reservoir of warm water to slowly accumulate in the western tropical Pacific. When that pent-up warm water finally released explosively as El Niño conditions took hold in late 1876, the resulting event carried a scale of energy and disruption considerably beyond what a typical El Niño cycle produces. Crucially, the 1877-1878 El Niño wasn't acting alone, and understanding this compounding effect is essential to understanding why the resulting drought and famine reached the catastrophic scale it did. Research published in the Journal of Climate examining this period in detail found that the extreme El Niño coincided with a separately record-strong Indian Ocean dipole, a related climate pattern that independently drives drought conditions across large parts of Asia and East Africa when it enters its own extreme phase, along with unusually warm sea surface temperatures across the North Atlantic Ocean at the same time. These 3 major climate anomalies didn't just happen to overlap by coincidence. Their combined effect produced what researchers determined was the most intense and second most geographically extensive drought to strike Asia's monsoon-dependent regions in at least 800 years, based on detailed tree ring reconstructions of historical rainfall patterns stretching back nearly a millennium. Multiple, independently severe climate anomalies stacking on top of each other simultaneously is precisely what transformed what might otherwise have been a serious but survivable regional drought into a genuinely unprecedented multi-continental catastrophe. It would be a mistake, though, to treat this purely as a natural disaster with no human dimension, because the death toll was significantly amplified by decisions made by the governments actually responsible for responding to the crisis. And this part of the story is worth understanding in detail because it directly informs why modern preparedness matters so much today. In British-controlled India, the region still produced enough foodstuffs during the famine's early stages to have theoretically avoided mass starvation. But colonial grain exports actually increased to record levels during the crisis, rather than being redirected toward famine relief, as the colonial government prioritized commercial exports and rigid free market economic policy over feeding the starving population under its own administration. Famine relief that was provided came attached to brutally punishing conditions. Workers seeking government famine relief were subjected to what became known as the temple wage system, named for the colonial official who implemented it, which provided famine relief workers with only about 450 grams of grain plus a single small cash payment per day of genuinely hard physical labor performed without shade or rest, a ration widely criticized at the time as barely sufficient to sustain the exact manual labor it required people to perform in exchange for it. Viceroy Lord Lytton personally oversaw the export of a record 6.4 million hundredweight of wheat to England during the height of the Indian famine, a decision that historians studying the period have consistently identified as making an already catastrophic natural disaster measurably, needlessly worse. Florence Nightingale, writing in 1877 as reports of the famine's scale reached Britain, described what was unfolding as a hideous record of human suffering that the world would need generations to fully comprehend. Now, let's turn to the question that should genuinely concern you, because it's exactly the question climate scientists around the world have been actively debating throughout 2026. Is the El Niño currently developing in the Pacific capable of rivaling or even exceeding the catastrophic 1877-1878 event? The early data heading into the back half of 2026 has genuinely alarmed researchers who study the specific climate pattern closely. NOAA's Climate Prediction Center formally declared El Niño conditions active on June 11, 2026, and the agency's own probability assessments have climbed dramatically as the season has progressed. In May, NOAA estimated only a 37% chance that this year's event would reach very strong intensity. By early July, that estimate had climbed to 81%, reflecting what researchers have described as extraordinary model consensus that this season's Pacific warming will exceed the strongest El Niño events measured since comprehensive modern record-keeping began in 1950. Some forecasting models have gone even further. European Center for Medium-Range Weather Forecasts has produced median ensemble projections suggesting Nino 3. 4 sea surface temperature anomalies could reach 3 degrees Celsius above baseline by December 2026, with some individual model scenarios pointing toward anomalies potentially exceeding 4 degrees Celsius entirely, a threshold that has never once been observed during the entire instrumental climate record. Paul Roundy, a professor of atmospheric and environmental sciences at the University at Albany, captured the scientific community's growing concern directly, writing publicly that confidence was clearly shifting higher on this potentially becoming the biggest El Niño event since the 1870s. It's worth understanding exactly why researchers keep reaching specifically for that 1870s comparison rather than any of the other strong El Niño events documented since, because the historical record here is genuinely narrow. Between the catastrophic 1876-1878 event and the well-known 1980-1983 El Niño, the modern era's first widely studied major event, climate researchers have identified only one other occurrence that could reasonably be classified as a genuine Super El Niño, a comparatively little discussed 1888-1889 event. In other words, events at the scale currently being forecast for late 2026 are, by the historical record, genuinely rare, occurring perhaps a handful of times across more than a century and a half of reconstructed climate history, which is exactly why scientists are treating current projections with such serious attention rather than dismissing them as routine seasonal variation. Here's where the story becomes genuinely complicated, and where the honest scientific answer resists a simple, satisfying conclusion in either direction. The world of 2026 is not the world of 1877, and in several critical respects, humanity today is dramatically better equipped to prevent a repeat of that historical death toll. Modern meteorology can track a developing El Niño months in advance with a level of precision 19th century observers couldn't have imagined, providing genuine lead time for agricultural planning, water management, and humanitarian response that simply didn't exist in the 1870s. Global food trade networks, whatever their flaws, allow food to move between surplus and deficit regions at a speed and scale that colonial-era transportation infrastructure couldn't approach. International humanitarian institutions, built specifically in response to disasters like famine, now exist to coordinate exactly this kind of response, and they're already actively mobilizing. The United Nations, Food and Agriculture Organization, and World Food Program have jointly launched an unprecedented, first-of-its-kind $202 million appeal, specifically targeting this developing El Niño's anticipated humanitarian impact, aiming to protect 8.8 million particularly vulnerable people across 22 countries before the event even reaches its projected peak. Broader projections suggest the current event could push as many as 36 million people into hunger globally, a genuinely severe humanitarian toll, but one that early coordinated intervention has at least some realistic chance of mitigating in ways 19th century populations had no comparable ability to access. But there's a second side to this comparison that cuts in the opposite, more concerning direction. And it's the reason serious climate scientists refuse to simply dismiss the worst-case framing as sensationalism. The 2026 El Niño isn't developing in a climate system anything like the one that existed in 1877. It's developing on top of a planet that has already warmed by roughly 1.4 degrees Celsius since the pre-industrial period, meaning any El Niño-driven extreme heat, drought, or disrupted rainfall pattern is now layering on top of a baseline climate that's already measurably hotter and, in many regions, already measurably drier than it was a century and a half ago. Jennifer Burney, a professor at Stanford's Doerr School of Sustainability who studies climate and food security, has been careful to note that exactly how severely this specific combination will play out remains a genuinely open scientific question, one researchers are actively working to answer in close to real time as this El Niño continues developing. What researchers do broadly agree on is that a Super El Niño striking a warmer, more climate-stressed planet carries the potential for genuinely amplified impacts compared to an equivalent event striking the cooler baseline climate of the 1870s, even accounting for humanity's dramatically improved capacity to detect and respond to the resulting droughts and disruptions. The current El Niño's effects are also colliding with a set of modern vulnerabilities that have nothing directly to do with climate science at all, but that meaningfully shape how much damage the resulting agricultural disruption could ultimately cause. Global fertilizer supply chains, already stressed heading into this event, face additional pressure from tightened shipping conditions through the Strait of Hormuz, linked to ongoing geopolitical tensions in the Middle East, a choke point through which a significant share of the world's urea and phosphate fertilizer exports must pass. UBS chief economist Paul Donovan flagged this exact intersection directly in a March 2026 analysis, arguing that nitrogen fertilizer shortages might not even represent the single biggest threat facing global agricultural prices this year, suggesting instead that the developing Super El Niño itself could prove to be the more significant destabilizing force. When a major climate shock arrives at the same moment that agricultural supply chains are already under independent strain from unrelated geopolitical pressures, the resulting compound risk to global food security becomes considerably harder to model, and considerably harder to guarantee a fully adequate humanitarian response to than either stress would represent entirely on its own. There's also a genuinely sobering ecological dimension to this developing event that extends well beyond agriculture and famine risk specifically. A Super El Niño of this scale carries the potential to intensify marine heat waves across an ocean system already stressed by decades of accumulated climate warming, with researchers at the World Resources Institute specifically flagging risks to coral reef systems, seagrass meadows, and kelp forests that support fisheries and coastal economies for millions of people in developing coastal and island nations. Previous strong El Niño events, including the well-documented 1997 to 1998 and 2015-2016 episodes, were both associated with major global coral bleaching episodes, and a genuinely record-breaking event carries the potential to inflict damage on these ecosystems considerably beyond what those already serious prior episodes produced, adding yet another layer of long-term economic and food security consequence, stacking on top of the immediate drought and famine risk driving most of the current humanitarian concern. It's worth understanding exactly how the FAO and WFP's unprecedented joint appeal is actually meant to function, because it represents a genuinely different model of humanitarian response than what existed even a decade or two ago, let alone in the 1870s. Rather than waiting for famine conditions to fully materialize and then mobilizing an emergency relief response after the fact, the entire premise behind this $202 million appeal is what humanitarian organizations increasingly call anticipatory action, using the months of advance warning that modern climate forecasting now provides to pre-position food stocks, distribute drought-resistant seed varieties, and fund early cash assistance in the specific regions. Climate models flag as most likely to be hit hardest, all before the anticipated drought conditions actually cause crops to fail. This approach has been tested in smaller-scale climate emergencies in recent years with genuinely promising results, but it has never before been attempted at the scale. This developing Super El Niño appears likely to demand across 22 separate countries simultaneously, making the coming months a genuine high-stakes test of whether this anticipatory model can actually deliver on its theoretical promise when confronted with an event potentially rivaling the worst climate disaster in recorded history. So, what should you actually take away from this genuinely uncomfortable historical parallel, watching in real time as it develops? The honest answer sits in a deliberately uncertain middle ground, and any content claiming absolute certainty in either direction, whether promising modern humanity is fully immune to a repeat of 1877's catastrophic toll, or confidently predicting an equally catastrophic outcome is already locked in, would be overstating what the actual science currently supports. What researchers do agree on, across every study and every expert statement gathered throughout this developing event, is that the underlying oceanic and atmospheric conditions taking shape right now genuinely rival the rare, extreme historical benchmark set by the 1876 to 1878 catastrophe, that the resulting drought and agricultural disruption carries real potential to push tens of millions of people toward genuine food insecurity, and that the ultimate human cost will be determined not simply by the raw intensity of the ocean temperature anomaly itself, but by exactly how effectively the modern world's early warning systems, humanitarian institutions, and international cooperation actually translate into action during the crucial months before this event reaches its projected peak. That's precisely the sentence Vimal Mishra of the Indian Institute of Technology Gandhinagar used when reflecting on why studying the Great Famine still matters today, telling reporters that understanding that historical catastrophe gives researchers a genuine sense of how to be better prepared because, in his words, it shows you this is the worst that could happen. Whether the world's response to the current Super El Niño ultimately proves that lesson was fully learned, or reveals that some of the same structural vulnerabilities that turned a severe drought into history's deadliest environmental disaster are still capable of resurfacing under the right combination of climate extremity and inadequate response, remains a story that's still being written in real time across the exact same stretch of Pacific Ocean that produced this catastrophe once already. Stay with this channel because we'll keep tracking every update on this developing El Niño and the global humanitarian response to it. And this is exactly the kind of story where the history genuinely could repeat itself if the world doesn't take the warning seriously enough, quickly enough,